Good morning, everybody. Today we're going to continue learning about degrees and radians, and specifically we're going to be looking at something called the angles of rotation, or how do we draw and represent certain angles on a coordinate plane. So for a little warm-up, we have to convert the following from degrees to radians. Well, these 4 degrees are very important: 90, 180, 270, 360. We'll show it in a second. They're very important angles to know for the coordinate plane. To convert to radians, we're going to do the same thing for all of them. We're going to multiply by pi over 180. That's always how we convert from degrees into radians. When we want to go from radians into degrees, that little conversion factor is flipped. So, multiplying 90 by pi over 180, etc., we would be able to get and simplify pi over 2, pi, 3 pi over 2, and 2 pi. I know I did that warm up kind of quickly, but by all means, just like in any part of this video, you should pause it, try to do the math for yourself, and then confirm your answer with the video, okay? But these are the 90, 180, 270, 360 converted into radians. Let's get into some vocabulary. So all the vocabulary is typed out for you guys, but make sure you guys are reading along, and you should be going back to your notes. Almost everything we do now is open notes, right? Whether it be homework, tests, or quizzes. So you guys should be going back into your notes and understanding this vocabulary. An angle is in standard position when its vertex is at the origin and one ray is on the positive x-axis. The initial side is the ray on the x-axis, and the terminal side is the other ray. So we're going to look at these two angles drawn. First, let's just understand what a positive and negative angle is. The angle of rotation is formed by rotating the terminal side and keeping the initial side in place. All that means is, notice how the initial side of the angle is just always, part of the angle is always that x-axis. It says always on that x-axis, that initial side. The angle is formed, think of it like a hinge. Alright? This angle is on the x-axis and opened up to form this angle right here of 135 degrees. Now, if this angle starts on the x-axis and we start by rotating it up, right? Up is positive. We call that a positive rotation. When it rotates counterclockwise, it's a positive rotation because it's going to rotate up from the x-axis. We call it a negative angle, or a negative rotation is when it starts on the x-axis and the angle starts to go down from the x-axis. So if you go down, it's a negative angle. And that would be rotating clockwise. Right? So sometimes people get a little confused because counter, that prefix sounds negative, but counterclockwise is a positive rotation and clockwise is a negative rotation. I like to think of it as, again, if I'm starting the x-axis and I go up, positive. If I start on the x-axis and go down, it's negative. So we want to practice drawing angles in standard positions. All right, so we're going to draw the angles 300 degrees, negative 150, and 900 degrees. In order to do this, we're always going to be drawing, we're going to do this kind of this one step over and over again, like a coordinate plane. Now, it helps to kind of label our coordinate plane. On the x-axis would be 0 degrees. And it's kind of on your unit circle as well. This would be 90 degrees, 180 degrees, 270 degrees, and we get back to the beginning. That's a full rotation of 360. Right? Then say this is from your unit circle. Our quadrants, or our 4 sections, 360 divided by 4 is 90. So each quadrant is a 90 degree. If I want to draw the angle 300 degrees, this is where it's a slight estimate. This is a positive angle, so I'm going to start on my x-axis and rotate up. This is 90 degrees, 180 degrees, 270. And now if I keep going, I can't go all the way to the beginning because that's 360. And 270 is not quite enough. So I want to go a little bit past 270 and say, okay, that's about 300 degrees right there. Now, is that an exact measurement? No, I didn't take out a protractor or anything like that, but it's just more of an estimate. I can see, again, that my angle is past 270 and it's less than 360. Well, 300 definitely fits that description. Notice I drew my angle a little bit, maybe a little bit closer to 270 because 300 is closer to 270 than it is 360. So again, when we draw these angles in standard position, it is a slight estimate, but we can get pretty accurate in our estimating skills when we draw. For negative 150 degrees, this is a negative angle. That means we're going to be starting by going down. Now, you might want to redraw your labels. Since I'm starting drawing a negative angle, I can say 0. This is negative 90, negative 180, negative 270, negative 360. Notice the quadrant angles are almost reverse now because I started going negative, so it goes down. Negative 90, negative 180, negative 270, negative 360. To draw negative 150, this would represent a negative 90. Now I can't go all the way back up because that's 180. So somewhere about there, we'll call this angle. Now negative 150 represents the whole angle, this whole angle. So this is my angle. That little circle just represents the amount the angle covers. So it's a negative 150 degrees. Now 900. Now drawing an angle like 900 means we're going to have to go around the circle more than once. So we're going to almost lap ourselves. So let me put on our labels. 0, 90, 180, 270, 360. So now when we draw this angle, we're going to go around this circle more than once. So watch how we're going to draw this. If I go one circle around, this is an angle of 360. If I go twice around, that's a rotation of 720. And if I go 720, I need 180 more degrees. That's a rotation of 900. For any skateboarding, snowboarding fans, a 900 is 2.5 full rotations. So, and we did 2.5 full rotations. One rotation was 360, another rotation was 720, and then half a rotation was 180 degrees more than that, and now that completes a 900 degree rotation. So this is 900 degrees. Now we can also draw angles in standard positions if it's set up in radians. Now you could convert all these to degrees, but we want to actually get into the habit of being able to work with things in radian format. So we don't always want to have to kind of rely on going back into degrees. When we draw an angle in standard position, if it's set up in radians, I'm going to want to label my axes in radians as well. This goes back to the warm-up. If you remember from the warm-up where you flip back, 90 degrees is pi over 2. 180 was pi. 270 was 3 pi over 2. And 360 is represented as 2 pi. So we have our radian setup. To figure out where 7 pi over 4 goes, this is a little trick that will help a lot of you guys is convert the quadrant angles into the same denominator as the angle given. So my denominator is 4. So I'm going to rewrite all these to have the same denominator as the angle that's given me. Pi over 2 would be equal to 2 pi over 4. Pi would be equal to 4 pi over 4. 3 pi over 2 is 6 pi over 4. And 2 pi is equal to 8 pi over 4. So just multiply top and bottom to get a denominator of 4. 7 pi over 4. Now I can use my new converted angles to kind of help me figure out where 7 pi over 4 will go. Well, 2 pi, 4 pi over 4, 6 pi over 4, 8 pi over 4. 7 will be in between 6 and 8, right? This is 6 pi over 4. This is 8 pi over 4. Therefore, 7 pi over 4 would be halfway in between them. This angle drawn is representing 7 pi over 4 radians. For negative 5 pi over 6, we're going to draw and our quadrants, but now it's negatives. So we're going to want to work in reverse again. So 0, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Again, negative angle, so I'm kind of going to reverse this because we're going to go clockwise in our rotation. To help me kind of figure out where 5 pi over 6 goes, because it's kind of tough to estimate fractions sometimes. We're going to convert all these to the same denominator. So if I convert everything that has a denominator of 6, so I'm converting everything that has a denominator of 6. Now everything has a denominator of 6, right? And all I'm doing is just creating common denominators. So I want everything to have a denominator of 6. So I can almost deal with these representations of our quadrant angles instead of their original fraction form. Now, negative 5 pi over 6, I got to figure out where that fits in. Well, this is 0. This gets me to negative 3 pi. I can't go all the way up because that's negative 6, and I only want negative 5 pi over 6. So I want to stop a little bit before that x-axis, because this is 6 pi over 6, so I want to stop a little bit before it to have negative 5 pi over 6 represented. My last angle is 11 pi over 2. This is positive, so we can draw it in the positive manner. This is my original labels. 11 pi over 2. Notice that this already is set up with over 2 as a denominator. So I'm just going to leave these original angle measurements. But 11 pi over 2 is going to take me a second to kind of get all the way around. So we're going to make sure we're going to convert that. Now, it might help to convert these to have the same denominator. This could be 2 pi over 2. And 2 pi could be 4 pi over 2. That way everything has the same denominator. Now let's count up to 11 pi over 2. So watch as we count, because we're going to need to go around the circle more than once. 1 pi over 2. 2 pi over 2. 3 pi over 2. 4 pi over 2. Now I'm just going to count a little bit fast. That's 4 pi over 2. Keep going. 5, 6, 7, 8, 9, 10, 11 pi over 2. So notice we have to wrap around the circle several times there. That's 11 pi over 2 for our angle. Okay? Alright, I know it's a lot so far, but we're almost done. Let me just wrap up with this concept of coterminal angles and something called reference angles on the back. Coterminal angles are angles in standard position with the same terminal side. Terminal side is just where the angle stops, where it ends, right? If we drew 120 and negative 240, they would actually end up in the same spot. I'll give you guys a rough sketch of that. Alright, I won't do this one as exact, but 120, 120 degree angle is about, looks like this. That's about 120 degrees. Negative 240 is, so I'll draw it below it. Negative 240 is the same angle. Notice these two angles, they're exactly the same. It's just They're represented slightly different, 120, negative 240. But they would have the same terminal side. The little trick to figure this out is we do this. If it's in degrees, we're just going to add or subtract multiples of 360. And if it's in radians, we'll add or subtract multiples of 2 pi. That's all you got to remember for this step, coterminal. Okay? So we're going to remember this step, but we're going to bring it to the next page. If I want to find coterminal angles of 40, 380, and 13 pi over 36, we're going to add and subtract multiples of 360. So we can do 40 plus 360 and get 400 degrees. Or we can also do 40 minus 360 and get negative 320 degrees. These are coterminal to 40. So what you add and subtract 360. We always want to have one positive and one negative answer. So we can add 360 again to find a coterminal angle to 380. And we'll get 740 degrees. Now, this one's a little kind of a special example because if we subtract 360, I get 20. Now, 20 is coterminal. 20 absolutely is coterminal with 380 degrees. But, like I said before, we'd like to represent our answer as one positive and one negative answer. So far, I have two positives. If I want to get a negative, well, I'm just going to subtract 360 again. 20 minus 360, and we get negative 340. All three of these are coterminal to the original angle. Typically, we would just say one of our positive angles and then this negative angle. Okay? 13 pi over 36. This does involve some fraction math for us. I have to add or subtract multiples of 2 pi. So we're going to add 2 pi. Well, now I need a common denominator to add these together. This is over 1 right now. So I'm going to rewrite this as 13 pi over 36. We're going to convert 2 pi over 1 to have the same denominator. Specifically, we're going to multiply top and bottom by 36. We get 72 pi over 36. When we add that together, we get 85 pi over 36. That's one coterminal angle. We also need to subtract. Now we're going to subtract by 2 pi, but 2 pi is going to convert into 72 pi over 36. So I'm not going to do that conversion again. You guys can save a little time there. You already know what 2 pi converts into, so we'll just use that value once again. Now we'll do our subtraction. 13 pi minus 72 pi is negative 59 pi over 36. These two angles are coterminal to 13 pi over 36. Okay? Our very last thing we'll cover today is called reference angles. Reference angles is another kind of different vocabulary word, but it's very important for our next section. Is the positive acute angle formed by the terminal side of theta and the x-axis. So if we draw an angle like this, theta represents the angle. The reference angle is, what's this part? All right? And this is going to help knowing your complementary and supplementary angle relationships. So it's just this like, what's this part here? The angle is here, what's this part in the gray? So if I have a reference angle, or if I'm trying to find the reference angle 150, I'm going to draw out 150 to start off. $150 we would draw over here is 150 degrees. So a reference angle is asking us, well, if that's 150, what's this part right here? Well, think about it real quick. This is 150. A semicircle all the way here is 180. So this little gap must be how much? That little gap has to be 30 degrees. We call that reference angle 30 degrees because 150 plus 30 is what will make 180. Or you could think of it in reverse and say 180 minus 150 is 30. So it's just the angle that's like, what's the other part? What kind of is the angle that connects to this x-axis part? That's our reference angle. And our reference angle is always acute. That's an important phrase. It's always acute, all right? Always an acute angle. And we're going to be using reference angles a lot in the next couple of days. If I want to find the reference angle for negative 130, first I'm going to draw negative 130 degrees. So that's a negative 130 degrees. To find my reference angle of right here, well, how many more degrees do I need to get back to my x-axis? It would be 50 degrees. Now, some of you guys might write down your answer as negative 50. I understand where you're coming from by putting negative 50. However, my definition of a reference angle is always positive. So we're going to say, okay, yes, it's in negative form. I get that. But 50 degrees is the amount that gets me back to the x-axis. So we just label it as positive 50 degrees. All right, my last reference angle, our last problem for today's notes, hooray, is 14 pi over 9. So first we're going to label my radians quadrants. And we're going to convert to have the same denominator. Now, notice it's going to be kind of tough to get my denominator converting from 2 to a 9 because they don't have anything in common. So first, before I do that, let me look at converting pi and 2 pi. There's a little trick for you guys. Pi would convert to 9 pi over 9, and 2 pi would convert to 18 pi over 9. All right? If this is 9 pi and this is 18 pi over 9, this has to be the halfway in between mark. Right? 9 pi, 18 pi over 9. Halfway in between that would be 13 and a half. That's halfway in between 9 and 18. Now, you can convert in a different way, but that's actually an easy way for us to see, okay? 18, 9, 13 and a half. 14 is a little bit past 13 and a half, right? So there's an angle right there. My reference angle is, how much is this part? How much is the part leading back to the x-axis? Remember, this was 14, this was 18, so this was 14, this was 18. The amount in between is 4 pi over 9. Okay? Good luck on the practice problems today. If you guys have any questions, just let me know.